Okay, so very good morning to all of you. Put the mobile inside. All of you have to put the mobile inside and just those who side just spread out. Okay, don't sit nearer. Okay, put some space. Okay. So see that in the last session we have discussed that whatever the EMF is induced in the armature coil. Okay, in the coil it is AC or DC. आप पंखा बंद बंद कर दें आवाज ना એ સાઈડ નો બંધ કરી દે તમારે નીચેનો બંધ છે ને આ ચાલુ છે હેલો હેલો હા ઓકે એટલે 178 ઉપર જાય તો ને હા 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 ઓકે ઓકે AC, it is AC. Okay, so remember this type of question asked in a MCQ or in the competitive exam. If the EMF induced in the armature coil, it is AC. Okay, but how you can convert it to the DC? By using commutator and brush. Okay, so if you have confusion in the last, so today I will show you one animation. So you can concentrate on the animation, what it want to say. Okay, so I will start this animation first of all. All of you have a hands free? All of you have a hands free? So if you want to hear the sound, you can on your mobile. Okay, so sound will be clear. See the picture over here and hear the sound from the mobile. So I will allow to you to take your mobile and you can also join. Okay. Just take a fast. It will, I will ask that if it is start, hear the sound. Are you not able to hear the sound? Are you able to hear the sound? Okay. Video no sound નથી આવતો? Now are you getting the sound? Okay, all of you are waiting. First of all, tell me now, are you able to hear the sound or not still? No sound is coming? Okay, 1 minute. One minute. Okay. Now we are able to see the screen.
No, giant that by giant turbine.
It is shows that there is a one giant turbine is there. Okay.
Turbine. Some power stations use very much.
In the see that there are different type of power plants are there. Okay. Some power plants are maybe the steam power plant. Okay, which is the work on the fuel is a steam. It means there is a coal is burnt and hence the steam is created and that is used as a fuel. And some power plants are use a hydro, means water is as a fuel. Okay, so maybe the hydro power plant or maybe the steam power plant, what is happening, there is a one turbine is required. Okay, and how the turbine, it is coupled with what, this generator. It may be DC generator, it may be the AC generator. Okay, because it is require a mechanical energy, so turbine will provide a mechanical energy because the flow of, you can understand, the flow of the water is coming. Okay, so the shaft of the turbine is rotating and hence the shaft of our generator is rotating. The generator is getting a mechanical energy. Okay.
Or water. Another example, and giant and then the wind the work for us.
Here it is shows that the water energy we are using for the generator.
Never really choose all giant turbine. But how much turbine some? Well, technology is on electromagnetic induction, discovered by Michael Faraday.
It want to say that each and every principle of any machine, it may be the motor, it may be the generator, it is depends upon the principle of Michael Faraday's. Okay, so what is that? So already we know that behind there is a magnetic field is there. So here you can say North Pole, here you can say South Pole. So flux line is coming out. Okay, I think up to it is clear.
Why?
Now we are putting a one conductor inside. Now we are putting a one conductor inside, which is rotating. Which is a rotating. So what it says that if when it is rotating, it will cut the flux lines. So the EMF is induced in the conductor. Okay, so now see, concentrate over here. Okay, the magnetic field is induced. Now we are using a one coil. So here you can see that we have used a one singleton coil. We have used a one singleton coil. So here for the simplicity purpose, the one coil side is represented for a pink color and the other coil side is represented as a blue color for the simplicity purpose. Okay, so whenever it will rotate, you can understand that which side is come under N pole and which side is come under the S pole. Otherwise, this is a single one wire is there and you have make this type of loop. Okay, so this is the one loop. Okay, that you have to put in this magnetic field.
And coil of wire.
See, now we are rotating by any means. Okay, by external means you are rotating this conductor or coil. So as you are rotating this coil, you can see it will cut the flux, yes or no? Okay.
Turbine.
See,
Coil starts.
how you can give the rotation by using a turbine. So turbine shaft is rotating, which is connected to the our DC generator. Okay, whatever the AC or DC generator, so it's this coil is also rotating. Okay.
And the wire starts up and down. That this can now light up. Lights are called convert.
Okay, now what we are doing? We are using this is called as a slip ring. Okay, so by using a slip ring and this white is a brush, we can give a supply to the lamp. So your lamp will be on and off. Your lamp will be glow. Okay, but still you are getting a AC supply. We will explain it.
So let's look at them. So let's start by figuring out what direction current is.
Okay, it is shows that say for example the current is flowing through this loop in such a way like this, say for example. Okay, so it will complete the path. Okay, so the current is flowing through this.
or generated well once it starts rotating. So let's say in our example, the coil rotates clockwise. So what like this. Now, how do we figure out the direction of this current?
Now here now we are going to see that how you can identify the direction of the current in the coil. Okay, here say for example this coil side I have represented by a pink color. So in this pink color the current is going inside or outside. Same way here in a blue coil side the current is coming inside or outside, that we want to see.
Well, we have already learned something called the Fleming's right hand general.
By using which rule we can find out the direction of EMF? Faraday's law. Faraday's law just says Fleming's right hand rule. Faraday's law says that when a rotating conductor is put in a magnetic field, it cuts the flux line. Up to this, it only says. But in the direction, the current is going where and current is coming out where, that can be found out by Fleming's right hand rule. Okay.
It says, stretch the fingers of your right.
Okay, so here you can see there is a right hand is taken. Okay, this is shows the F for force, or we can say the rotation. So whatever the direction of the movement of the conductor, it is represented by F, means force, or we can say rotation direction. This is the direction of magnetic field. D means flux density. So this yellow line, this yellow finger shows the flux density. That is our fourth finger, and this middle finger, it is representing the direction of EMF and hence the current. Is it clear? Okay. So you have to take your right hand, stretch out your thumb, fourth finger and middle finger. Is it clear? Okay. So see here the direction of rotation, direction of magnetic field and direction of the current. Okay. Now we will apply to here.
Then the thumb represents the direction of the motion of the.
Okay, the thumb is representing direction of motion, means it is your coil is rotating upward or downward. So say for example, in this present, if you are rotating clockwise, if you are giving a rotation clockwise, then this pink coil side is going upward or downward? Upward. And this blue one is downward. If you are giving a clockwise rotation, yes or no? For particular moment, okay?
Wire. The direction you're pushing the wire. The forefinger is the direction of the. Then our middle finger will give us the direction. So all we have to do is align our right hand. Make sure the thumb and the forefinger point in the direction of the motion. Then the middle finger will give us direction. So let's use our right hand on the pink wire that is going upwards and on the blue wire that is going down.
Okay, here we are giving a clockwise rotation. So think in your mind that this pink is going upward and this blue is coming downward. Now, how we can find out the current direction?
So it'll be a great idea if you can first recognize yourself. Go ahead, use your right hand. Figure out the direction of the current. Blue one. All right, you've done it. Let's first start with the pink wire. Because the pink wire is going up, the thumb should be pointing upwards. The magnetic field is to the right, so the forefinger should be pointing to the right. So if we align our fingers that way, it will look like this. The middle finger is pointing inwards. This means the current in the pink wire must be similar.
Now see, this finger shows the direction of magnetic field N to S. Okay, this pink wire, it shows upward movement. Why? Because we have given a clockwise rotation. And see the middle finger is going inside or outside? Inside. Okay, so you have to say that the current is going inside for this pink coil side. Okay, so see over here.
For blue wire, the blue wire is moving down. So the thumb will be pointing down. The forefinger will still be pointing to the right. That is our right hand over here.
Now see, So this hand shows the movement of the current in this pink color. And now for the blue, see the direction of rotation, it is downward. Okay. The direction of magnetic field is as it is N to S. So this finger, see this finger, middle finger. Are you getting? It is coming outside. Okay. So from here, blue wire, the current is coming out. And here the current is going inside. See the finger. This finger, it is goes inside. And this finger, fourth finger. So in this figure, what you have to observe? Observe the direction of middle finger. Direction of middle finger for the pink wire and blue wire. So in the pink wire, you can say it is going inside. And in the blue wire, the fourth finger is coming outside. You can say, sorry, middle finger. Okay, see the direction of middle finger, which shows the direction of current or EMF. Is it clear up to this? Yes or no? Okay.
It will look like this. You don't think it's pointing out of the screen. That means the current, the blue wire, coming out of the screen. So what we have seen is the wire is going upwards over here, then the current will be into the screen. And if the wire is going downwards, then the current will be out of the screen. Remember, this will be important. So now let's get rid of the arrow marks.
Is it clear? So up means into the screen. Screen means you have to understand projector. Okay. So already I told you you have to assume the arrow. So this is going inside. So it is going into the screen. Okay. So you have to assume that this is the magnetic field. The thumb is going upward. Okay. So this is magnetic field. Right hand rule you have to take. So for this side you can just I have to come or you can understand. Okay. Take your right hand and just verify. Are you able to find out the same direction? Yes or no? તમારા હાથે થોડી તસદી આપો. થાય છે બધાને? Have you done? Okay. I have come. Okay, now see. So take your right hand. Okay. The N to S, it is your magnetic field. Okay. The pink color conductor is moving up because I am giving the clockwise rotation. So this thumb is my up. Now see the middle finger. It is going inside. Okay. So here you can see this finger is going inside. That is magnetic field. Okay. So if the rotation is upward, this finger is going into the screen. Yes or no? If that finger is going into the screen, so here it is into the screen. Okay. So this we can blue is showing the into the screen. Now come to this side. If you are getting a clockwise rotation, this is coming downside. This blue wire, so put the downside. Okay. The magnetic field is as it is N to S. So see this one is downside. The magnetic field is as it is N to S. Okay. So now observe the middle finger. Observe the middle finger here. It is coming outside. So it is out of the screen. Yes or no? This is the screen. So this finger is coming out. So out of the screen. When your movement is down. When the movement is down. When the movement is up. The current is into the screen. Here it is. Yes or no? Okay.
And now we can guess what direction the current is. The rest of the wires. The current has to flow from the pink to the blue, then the current has to move here like this. And the current has to move here this way, goes down, goes to that external circuit where there's a bulb, and then here, and the current comes back like this. And the current continues.
Okay, so now see this is the into screen. So inside here the current is coming out. So this shows the direction of current through this coil. Okay.
To go like this as the coil is rotating. Because you can see the pink wire is still going up, and the blue wire is still going down until we come to this point. Because now the pink wire starts going down. Now the blue wire starts going up. Yeah, go back and come back again. Notice the pink wire is coming down, the blue wire.
Okay, so here you can see. Just a second.
The rest of the wires, since the current has to flow from the pink to the blue, then the current has to move here like this. Then the current has to move here this way.
Okay, it just shows that this way the current path will be completed.
Down, goes to that external circuit where there's a bulb, and then here, and the current comes back like this. And the current continues to flow like this as the coil keeps rotating. Because you can see the pink wire is still going up, and the blue wire is still going down. Until
Okay, now see up to this the from here to here 90-degree movement. Understand? First of all, the pink wire was here, yes or no? Now it is go up, and it is like this. So up to the 90-degree rotation, its movement is upward. Okay. Now see, now what happened? Now this pink is going downside, and this blue side is coming upside, yes or no? So now see the direction.
from this point. Because now the pink wire starts going down. And now the blue wire starts going up. Yeah, let's go back and come back again. Notice the pink wire is coming down, the blue wire is coming up. This means now the current in the pink wire should be out of the screen.
So now here it should be changed now, yes or no? So now see the arrow will be changed now. It should not be now inside, it is now outside. So just a second, it will change the direction.
Current is now direction. This is important.
So here the direction will be changed. See now.
And it continues to flow.
See here, the direction is changed now. Obviously, because now it is under this downside movement. And this blue one is a upside movement. So direction will be changed. Okay. So if the direction will be changed, the current direction is also changed. So now it is coming out, it is going on. Okay.
Here again the pink wire comes on the left side. Now again the pink wire starts going up, the blue wire starts going down. As a result, the current is
Okay.
inwards. The current in the blue wire will now be outwards. The current will again reverse. So every time our coil is in this position, which is perpendicular to the magnetic field, you will see the current direction. So if you look at the entire animation now, it looks somewhat like this.
See here how the
Every
direction
time
is changing.
the coil comes in this position, perpendicular to the magnetic
Okay, after each revolution, the direction of the current through the conductors will be changing.
I'm stopping, I'm pausing the animation when my coil is perpendicular so that we can see the current in this direction. But of course, in reality, the coil will be pushed back. There's no stopping. There's no jerking motion like this. Now, the next question might
Okay. 1 minute.
how do when external start? Oh,
Okay, now see here, we want to supply this current to this lamp. So here we have taken one lamp and now we are going to connect the this lamp with this, we can say coil. But as the coil is rotating, what happens? If you directly connect, then your lamp is also rotating. Okay, so how we can make this
well,
arrangement?
direct. Let's see what happens. Current will
Okay, it is connected.
but as the coil starts, notice the wires start.
Okay, if you are directly connected, then what happens is the coil is moving, your wire is also moving. Okay, so what happens? It will make a one flush. Okay, you can say that it will be mixed up. Okay, so here you can see the wire is also moving.
That's going to be a
So it
problem.
is not a perfectly. Okay, so how you can do this?
The wires direct
So you are not able to connect wire directly, otherwise your lamp is also rotating.
forward brushes and
So now how what you will do?
looks somewhat like
Now you are connecting the slip rings. You are connecting the slip rings. Okay. So see here, there is a blue slip ring and there is a pink slip ring you can see. Okay. So this blue wire is connected. See this line. See the arrow. Follow the arrow. This is your blue pink conductor. The pink conductor is connected with this pink slip ring. Yes or no? Okay. And then it is connected to brush. Okay. Now see here this blue wire. The blue wire is connected to the blue slip ring. Yes or no? Okay. So that is the way. And these are the brush. Now your slip ring is moving and your brush is stationary. So there is a sliding contact like this. Okay. Your slip ring is moving but brush is fixed. Okay. So as the brush is connected with a lamp and brush is not rotating, so your lamp is also not rotating. Okay. Now see how the it is working is possible.
have
Is it clear how the connection is done? See, this pink conductor is connected with only one pink slip ring and this blue conductor is connected with this blue slip ring. Okay, both are connected with a different slip ring. Okay, and this is nothing, it is a one copper ring.
and
Copper.
what not come from a diagram that connect one wire to the left wire, blue ring, the right. And these wires are connected to carbon brushes and they are just touching but they're not stuck. So right now there is a contact. And as a result, the current comes out of the blue ring.
Okay, so now here what is happening, if we will see that, then the current is flowing from a blue wire, sorry, pink wire, then it is going in the blue wire, then it is going in a blue slip ring, then it is going in this brush, then it is going to the lamp, then it is going to this brush, and then pink slip ring, and again in a pink wire. Okay, so that way the path will be completed. Okay, you can give a name the slip ring A and B, whatever.
Current flows into the and when the coil starts rotating,
Now see, now the coil has started the rotation, but still the pink slip ring is connected to what? This pink one. Okay, and so the path is again still it is completed, direction is proper. Now what happens after the half revolution? Observe this.
rotate along with the coil. But since the brushes are not stuck, the ring is just into the brushes. That's why they're called as slip rings. As a result, the brush is not rotating at that solves the problem of wires. All the wires get in contact. Now, once our coil comes to this position, see that the current reverses.
Now see, now the current will be reversed. Here the current is coming out, here the current is going inside, okay? So now how the circuit is completed.
So now the current will flow out.
Now see how the current will be flow. Here the current is going inside because already we have seen it is going upward direction, okay? So upward means the current is going inside. So here the current is going inside. Here from the pink wire the current is coming out. Then it is goes to where? Then it is goes to where? Pink slip ring. And from pink slip ring it is going to this brush because this brush is connected with what? Pink slip ring. So now the direction of the current through the lamp is changed, yes or no? See here, before what was the direction? Concentrate over here. Before that the direction was this one. Before that the direction was this one. But after the rotation, see the direction is changed. Direction is changed, yes or no? Okay. So here now the path is, the current is going in a blue wire. Then it is coming from the pink wire. Then it is goes to the pink slip ring. From pink slip ring to this brush. Then lamp. Then this come in this way. Then it is going in this brush. Then goes to the blue slip ring. And blue slip ring is connected to blue wire. Is it clear? So what happens? The direction of the current through the lamp is changing, yes or no? In a one half the direction is different. And in the second half the direction is different. So still the EMF is induces which type? AC. The current is AC. Okay. So if you are connecting the slip ring in such a way, like this, then it will give a AC output. Okay. Now, how you can connect?
The current is what is
So see it will blue and pink. It will be change the current direction. See, the current is changed. See the direction. Now when the direction is changing, see the continuously the direction through the lamp is changing.
so we have successfully built our generator.
So here you can successfully make a AC generator because output is AC. But now we are going to convert into the DC. So for that, what you have to do?
The current from that generator direction. Such a current is called alternate or DC. And this might sound a little weird, but it turns out that when you want to transmit electricity over long distance, like from the power station to your houses, then alternating currents.
So this is called as alternating current. Which type of current is passing? Alternating current, AC current.
What is over unidirectional currents or so that reason, the current that we get at our houses are all these generators are called DC generators. Finally,
This is called as a AC generator. Why? Because the output is AC.
what if you want to do where you don't want the current direction? What if let's say this yeah. Well, first let's get through this. All right. And make sure that the current direction.
Now see, now what changes we are going to do? These are the brush. Okay, now which type of construction come over here that we have to interested?
What this brush is.
If you can keep the same direction of the current which is passing through the lamp, then it means what? This brush should be always connected with which wire? This direction of current means pink one. And this brush should be always connected with the current direction. Which conductor have this current direction? Okay.
Contact wires every carbon. Let's see one. So if I want the current to flow right now, this one, I can connect this brush to this wire. Comes out. But as the coil rotates, notice once it comes to this position, you see that the current starts flipping. Reverses. So now, the current in the same direction.
So one time this brush has to be connected with blue one, and after half revolution, this same brush should be connected with pink one. Again, after revolution, blue one, pink one. So this brush has to be connected in a different. In a previous, what happens? It is connected to the only whatever the oil side is there. Okay.
The blue side. Then again,
Now then, see, it should be connected with pink one now.
again you would want now this brush.
Okay, this brush has to be connected with pink one.
So as a result,
So how you can do this? That we will see.
you would want the contact. How do we make sure that happens automatically? Do that by attaching this.
Now see, now we are using, this is called as a split ring. Split ring. Okay. So here you have a, there is a one ring is there, but you have divided into two sections. Okay. So here you can see there is a pink slip ring. It is called as a segment. Okay, commutator segment. And this blue one is a half. It is called as a, again, commutator segment. So here you can see. Now, as this one is rotating, this blue is always connected with this blue wire. And this pink is always connected with this pink wire. Are you getting? This particular half section, which is pink one, is always connected with this pink wire. And this half commutator segment blue one is always connected with this blue one. So as your coil is rotating, this commutator segment is also continuously rotating. Okay, but your brushes are not rotating.
Half some gap. Now let's see how this arrangement automatically contact with the other. Right now, this brush is in contact with the inside. As the coil rotates,
Now see this figure first of all. It will take 2 minutes. Okay, now concentrate on the figure.
right now,
Right now, this slip ring is connected with this pink wire, and this brush is connected in such a way, and see the direction. See the direction. Okay, now see that.
brush is in contact with the inside. As the coil rotates,
Now see, as the pink wire is moving, this pink slip ring is also moving. Now after half revolution, see what happens.
current first
Now the current direction is changing after half revolution.
now notice the brush is in contact with the blue side.
Now see, the brush is now in a contact with which brush? Which slip ring? Blue or pink? Blue. Okay, so see the direction. The blue one has a which inside current. So how the path is completed? Inside, then go in the pink wire, then go in the pink slip ring. Yes or no? And from pink slip ring to this brush, because this brush is connected with pink one. Yes or no? So pink to this brush, then it is goes to in this line, then it is come to in this brush, and this brush is connected to where? This blue one. Okay, and this blue one is connected to what? This blue wire. Okay, so the direction of the current is remains same.
Making sure the current still flows in the same direction.
So current is flowing in the same direction.
Yes.
See here, you are getting a complete idea. So pink wire, pink through this pink slip ring, and this brush, then it goes to this lamp, then in this brush, then it is goes in this blue slip ring, and this blue slip ring, see, the blue slip ring is connected to where? With a blue wire. See this connection, blue slip ring is connected with blue wire. Okay, and this pink wire is connected with pink slip ring. Okay, so the current is flowing in the same direction.
As the coil comes down,
See, whatever the now coil is moved,
another path.
the current is remain same. Yes or no?
Now in contact.
Okay, so that way now we are getting a DC current.
This
Okay,
way. And
so now we are free. Again, you can come at 11:50. Okay, after 15 minutes. Okay, you can join after 15 minutes. Okay, I will put a link. So this way the DC generator, you are getting a DC output.